Hello, this is Ladislav Smola. I'm a Reddit engineer, and today I will show you the integration of ManageIQ with Instack, which is OO-based installer Red Hat uses. So what you will see is a work in progress, so not all pages are finished, and we are missing a lot of things, and there are also some bugs, but we can do a walkthrough of working features. So let's log into ManageIQ. Now this is a completely blank ManageIQ. So what we want to do now, we will add provider that serves as infrastructure, that is Undercloud in OO world. So we will name it Instack. We get the password from our stack RC. User is admin. We can validate the credentials, so context keystone and check if it's okay. Seems like it is alright, so we can add our Undercloud to ManageIQ. This will just take like 30 seconds to refresh the inventory, so we should see our Undercloud in here. Let's skip a bit forward. Now you can see it refreshed. This means there are 4 hosts. So let's look into the provider detail. Right. So we can see some aggregated statistics. We can see it has 1 orchestration stack. Templates are images. We can see 4 hosts. Clusters, we'll look at it later. So let's just go to the list of hosts. And we can see 2 of them are running. In the name you see this one is controller and this one is compute, and we have 2 free nodes. Okay, so next step will be to add also our Overcloud to ManageIQ. So that is the end user cloud, so let's go to the clouds providers. And let's add a new cloud provider. OpenStack, host name is this, and this is the admin password. Now this is a step where we connect Undercloud to Overcloud, right? So this is the provider we created, and this provider actually manages this cloud. Right now this relation is done manually, but in the future it can be done automatically. So when you will add Undercloud into your infrastructure, it will basically auto-discover all deployed Overclouds. So let's do the relation manually for now. Credentials are valid, so we can add our Overcloud. This will again take about a minute to refresh all the inventory, so let's just skip forward. And it's done. You can see we have 1 VM in our provider. So let's just quickly check it out. It has 1 image, 1 VM, some security groups, flavors. So this is the end user cloud. Now let's see what happened on the infrastructure side. So let's move to the host section. And we can see we have actually association with the VM now, right? So controller, it says 0 VMs, there will never be any. And the compute node has 1 VM, so let's go into the detail of the compute node. And we can see a relation here that says 1 VM. So we can follow that relation. And that actually shows us list of VMs on the host. There is only one. Okay, so this is host themselves. Now for the roles concept, as you know from Taskar UI, we use clusters now for modeling that, although we will probably rename it in the future or move it somewhere else. But for now, we have it used for grouping nodes into roles like structures. So you have Overcloud controller cluster and Overcloud compute cluster. So let's drill down. So you can see here how many nodes you have in your, let's say, Nova Compute role, and how many VMs you have there, right? So this is like the global view on the role level, right? And also the aggregated statistics that we are collecting now. We are not collecting them all. Okay, so the next important feature will be monitoring. So we need to first allow the monitoring and collecting of the metrics. So let's do that. It's in configure configuration. And we allow order capacity and utilization workers, and also automation engine. We will need that later. Okay, so now it will take around 10 minutes to collect all the metrics, so let's just skip forward to that. Now you can see we skipped almost 2 hours, so we didn't have data in Ceilometer up to like half hour ago. So then we started to collect it, and for the metrics we actually need the hourly rollups. So first hourly rollup was on the 11 AM UTC. So let's check the statistics. So this will be the compute node utilization. We don't have any daily rollups, so the charts are empty. Let's look at the hourly rollup. And you can see we have only 1 point, right? So this is the first hour we were collecting the data, and here you see correlation to running VMs on the host, right? So one running VM, and this is the real-time memory consumption. Also the other statistics like disk I/O, network I/O. Now, not all the statistics are collected, so basically just the memory and the disk I/O and the network are. Now we can look at the aggregated statistics. interesting in our compute role. So let's check the utilization here. Let's check the hourly statistics. Okay, now on the memory you can see where we started to collect the data. So 9 hours rollup didn't actually have the data. Only the 10 hours had. Right, so you can see the running VMs and running hosts correlation here. It's still the same. There is one compute host, and on that there is one running VM, and there is aggregate statistics of that, so it will be more interesting when we will have more data. And there is running number of hosts in time. Okay, so these are the basic statistics. We can move to another part. Now let's move to the scaling part. That means we will want to add more compute hosts. Now we can either do it manually, which we will go through later. So there is a very simple scale action prepared, so we can actually set the number to each row. But for now, let's show the auto scaling feature. Right, so we will, based on some conditions, we will want it to increase a compute number, for example. So first we will need to set up an alert. So I have it already prepared, so we'll just import alert that is based on real memory consumption. One. You can, from CFMU, you can export and import the alerts and the automate you create, so we can share it with more people. So let's see what we have added. It's this one. So it's based on cluster, on real-time performance, and this is the average usage of memory. For this use case, it would be better to have actually allocated memory by deployed flavors, but for testing purposes, this is enough. And there is a bug in CLmeter that instead of used memory collects actually available memory. So this is saying that it has to be if there is a less than 50% available, right? There is a backport for it already done, so it will be fixed soon. So when we have the alert, we need to create alert profile. And just last thing, this is the event it will send when the alert will fire, right? So when the condition is true, it will send this event. We will catch it later. Now, when we have the alert, we need to create alert profile. It will be cluster-based alert profile. We will pick this. I will call it auto scale. Right, so these are the cluster-based alerts, so you can choose one of them. Now, we need to assign certain clusters for this alert, right? So I want selected cluster, and I want the auto-scaling happening only on Nova Compute, right? So it will actually observe only Nova Compute role or cluster in this context, and based on average real-time memory usage of the whole compute role, it will shoot the alert. Right, so this will connect alert and the Overcloud Nova Compute cluster together. So now it will shoot me the event to the system I defined in the alert. So what I need to do, I need to catch the event and do something with it. So I have a custom automate script prepared for handling the event. So again, we will just import it. We will import all. There is automation system. We will go through it in a second. So let's go to the Explorer and see what we have actually imported. Now we have a new domain Instack, and we import these two sections. So important is this one. This is the event catcher, right? So you just define that when this event is catched, you will do a relation to this script, right? The path is automation autoscale, Instack autoscale processing. Right, so the request is not related now, yeah, but you can also catch the event. You can do a request, and you can tie, for example, a button to it in the UI. So the event is catched. The relation is to this script, right? Instack automation autoscale. So it will go to this class, and there is only execute method, which is called Instack autoscale processing, and the method implementation is here. So it's very very simple implementation. You will take the cluster it sent to you, so it's the cluster the alert appeared on. From that you will get to the provider. We will get current compute hosts count, so just very simple filter. We will get to the stack, and here, because we have homogeneous hardware, I just count number of nodes that are powered off, and I take it that those are free nodes. So if there are still some free nodes, I will just increment the compute host count by 1, and I will send it to heat, right? So this is just updating stack with different parameter. It's actually updating taskr, and then the taskr content is sent to heat, right? Otherwise it will log that there are no free hosts for autoscale. So this is very basic scale up of the compute role. So once we have this, you just need to enable the domain. Now we are ready for autoscale. So let's move to the section where we actually trigger the. So since the autoscale is actually triggered by memory, we can easily trigger it by deploying more instances to the Overcloud, right? So let's we'll provision instances. We will use the Instack Overcloud image. Let's call it test. And let's put there small flavor. This should be enough to reach the 50% condition. So let's deploy the VM. You can see the request for creating VM was created. The logic for approving the request is set to auto approving. So we will just wait till the dual code go through. Okay, it was approved. So let's go to the cloud provider and wait till the VM is provisioned. We still have only one instance. Okay, so let's skip a bit forward again. Okay, we can already see there are two instances now. For now we need to do manual refresh with this button because we don't have integrated OpenStack events yet. So in the future this will work like the event that there is new instance being provisioned will trigger that we will refresh the data. So let's look at the instance list. You can see two instances, both are running. So let's look how that affected hosts. And you can see that the two instances are on this Nova compute now. So that's good. Now we need to wait for the autoscaling and for the another hourly rollup so we can actually observe it in the chart. So for the autoscale event we can go to the cluster timelines. And we can check for that. So we will go to timelines. It says no records found yet. Let's try if we have some alarms. And we can see the alert is already there. Right. So it was 11:25. So basically sometime after we set it. Remember that this is the real-time memory usage, so and there are operations on the node that can be bigger, right? it's not the actual flavor reserved capacity. Okay, so let's see if this event actually fired before we had the automate connected to that or not. We can refresh infrastructure provider. Again, this would be done automatically because the event of changing heat would be caught. It is still create complete, so it hasn't been connected to automate yet. So we will have to wait for the another alert shooting. Another way we can observe it is in automate log. So let's go there. Let's search for autoscale. So you can see here that the method hasn't been found because we haven't connected the alert to the automate yet. So we will have to wait until another alert will shoot, and it is connected now to the automate. So let's skip forward. It can take like 50 minutes till the next metrics collection will be done. Okay, so it's approximately 50 minutes later. We can see in the log there has been another event. Now it found the automation script. So you can see this. Autoscaling method started. It prints the cluster. Autoscaling to 2 from 1. That's just what it prints, and ending, right? So we can go to the provider detail. And we can see that the overcloud status is update in progress, right? We can get more info from the heat section. This will be actually presented in another demos. It's not entirely finished, but you see that the heat is update in progress. At some point you will be able to click through the nested stacks and see the real state. So let's go back to the cluster-based timelines, so we can see the timeline alert that happened there. Okay, you can actually see 2 alerts happening, one in 12:16, one in 12:22. So it doesn't matter much because it can run it twice since the heat is blocking it. Right, so we can nicely watch here what alerts were shooted. You can see it is the associations, right? So it is Nova Compute cluster in Instack provider. This is only for one cluster. You can see the same statistics on provider level. So for all clusters or all rows, right? Let's just quickly show that. Right, so we will see the same, but then you will have here alerts from all associated entities. So if there will be alert for a host, you will see it. Alert for every cluster, you will see it here. Or you can dive it to cluster/roles and you see alerts just for that particular group. Or the same should be in hosts. You will go to host timelines and you will see alert for that particular hosts. Okay, so let's skip a bit forward and wait till the stack is updated. Then we have to wait for another refresh, and the alert should go away once the memory utilization will reach more than 50%. Less than 50% in this case. So let's just show the statistics to see if the condition was really met. Right, so this is showing the available memory. So you can see is actually less than a half. It doesn't even catch the upload, the deployed VM yet, and it was less than half even before that. Right. So okay, let's skip a bit forward so we can watch the increased number of hosts and increased number of VMs, and if the condition will go away with that. We can see a next statistical arrived. Now it actually shows the change of the VM. So the next one should show what happens with the autoscale. Let's just quickly watch what is happening with the alert. Okay, so we can see a lot of alerts actually. Last one was 15 minutes ago, so it was after it actually finished the deploying. So we can see that some of those are probably failures, that alert is set badly. It's checking it every minute or so, and it was probably failing to update its stack, and also the memory condition is not probably the best, but seems like it has stopped after the scale up, and seems like it could have been more scale ups of one after another. So let's see how many hosts we have now. and we can see we have actually reached the limit. So the memory condition was always true, so it just kept scaling after it ran out of the space. We can show what is the last log. So this is actually the first one, auto-scaling to 2. And the last one is, okay, so after it is actually scaled to 4 nodes, there was still the alert, so still not enough memory. But since it's real memory, it means when it was doing something, it was actually spending a lot of memory. So if the condition should have stopped, it would be better to use reserved memory by deployed VMs. Then it would not be the volume that is changing that much. So it's actually not that good metric we are using. Nevertheless, the auto-scaling has stopped when there are no more nodes, right? And that was the last alert we saw in the timeline. There were no others since that time. Okay, so we can just wait for some time to see if the statistics will be clean now, and to observe all this in the charts. So we have moved enough forward in time, so let's just check the final statistics. Let's just look at clusters. And visualization. So we can see the correlation of deployed nodes. So in the 1 hour there was actually auto-scaling twice, from 1 to 3 and 2 VMs. You can see that the available memory is now bigger than half, so it doesn't shoot the alert anymore. The same as the other stats, you can see how the aggregated statistics have risen mostly, seeing number of hosts in time and number of VMs in time. So, and we can just check that it doesn't throw the alert anymore. If you have noticed, the utilization is not showing the last sample, so there is a bug in the chart. That's why we don't see the actual volume, or like this hour volume. Okay, and the last alert was catched 12:50, right? So it's in the interval from 12 to 1. So that seems to be correct. It doesn't throw any more alerts, so the alert is working. And that's probably all I wanted to show. So, as I said, there are still minor bugs. It is work in progress, and there is still a lot of work to do by fixing and polishing the stuff we do, also with adding a lot of new stuff. So that's all from me. Thank you for watching, and see you soon in the next video.